Grace and peace to you all, and welcome to my second video on logarithms. This is Donald Siame, author of Hidden Mathematical Genius Within Revealed. Okay, so today's question, we'll look at the relationship between logarithms and index notations. Okay, so we need to know or remember this law. When you have log of b base a is equal to x, so log of b base a is equal to x. This can be expressed in index notation as, so this is our base and this x will be our power. So this will be b is equal to a to the power x. So this will go there and the x there will be our power. So this is the law which we are going to apply. Okay, let's go to the questions now. Solve the following equations. So we have log of x, that's number 1. We have log of x base 10 is equal to 4. So what you do is, this is a base and this will be the power. So x is equal to 10 to the power 4. And 10 to the power 4 is just 10 times 10 times 10 times 10, 4 times. That is x is equal to, so 10 times 10 is 100, times 10 is 1000, times 10 is 10,000. So x is equal to 10,000. That is number 1. Number 2, we have log of x base 3 is equal to 2. Again, this base will go there and this 2 will be the power. So we are going to have x is equal to 3 to the power 2. And 3 to the power 2, we know that is 3 times 3. So x is equal to 9. Okay, number 3, we have log of x base 4 is equal to minus 2, 1 over 2. So here, since we have a mixed fraction, the first thing is to convert this to an improper fraction. Okay, so to convert to an improper fraction, you just multiply the denominator, the whole number, by the denominator, then plus the numerator over the denominator. So we are going to have log of x base 4 is equal to negative 2 times 2 is negative 4, and the negative 4 plus 1, you get 3. Okay, let's do this. It's 2 times 2, that is 4. 4 plus 1, that is 5. So you get 5 over 2. Negative 5 over 2. Okay, now we can express them in index notation. So in index notation, this is our base and this will be our power. So we are going to have x is equal to 4 to the power negative 5 over 2. Okay, so when you have a negative power and want to make this positive, we introduce a 1. So this will be 1 over 4 to the power 5 over 2. So now the 5 over 2 has become a positive. So whenever you introduce a 1, then the power will change the sign. Okay, so we have x is equal to 1 over, and again, you should remember that when we have the power of the fraction, let's say we have x to the power a over b, you should know that the denominator from that power gives the root. Then the numerator will be the power. So x to the power a over b simply equal to the b root of x to the power a. Okay, that is according to the laws of indices. Okay, so here where we have a fraction power, this denominator 2 will give us a root, and the numerator will be the power. So we are going to have the second root, that is square root. So it will be square root of 4, then to the power 5. So we are going to have x is equal to 1 over square root of 4 is 2, and 2 to the power 5 is 32. So it's just 1 over 32. So that is the answer. And the next one is log of x base 8 is equal to negative 4 over 3. Okay, log of x base 8 is equal to negative 4 over 3. So again, this will go there as our base, then the negative 4 over 3 will be the power. So we are going to have x is equal to 8 to the power negative 4 over 3. Again there we have a negative power. So when you have a negative power, we introduce a 1. So it will be x is equal to 1 over 8 to the power 4 over 3. So the power has become a positive now. Okay, so x is equal to 1 over, so I said when we have a fraction power, the denominator gives the root and the numerator is the power. So here we have a denominator of 3, so we are going to have the cube root of 8, then power 4. So it will be cube root of 8, then power 4. So x is equal to 1 over cube root of 8 is 2, and 2 to the power 4, that is 2 times 2 times 2 times 2, you get 16. So this is 1 over 16. That is the answer. Okay, and number 5, the last one. So the last one we have natural log of x is equal to 3. Natural log of x is equal to 3. What we should always remember is that the natural log of x simply means log of x base e, that is exponent. So the natural log, the base is always an exponent. Okay, so here the natural log of x is equal to 3. There is an exponent, there is a base of an exponent there. So the base there is e. So to simplify this one, or to express it in index notation, we have the base there is e, so the power will be 3. So we are going to have x is equal to exponent of 3. So x is equal to, we can just do this direct on a calculator. So we'll say it is exponent of 3. So you shift, exponent is there, then 3. So you get 20. So we have 20.08553653692. Then we can round off to 3 significant figures. So it will be 20. So 3 significant figures, we end at 0 there, and the next digit is 5 and above, so you can add the 1. So we have 20.1. So this is how you do it. So for these questions, we have used the relationship between logarithms and index notation. So we said when you have log of b base a is equal to x, this is expressed as b is equal to a to the power x. So this base will go to the other side of the equation, and what you have to that other equation, it will be the power. Okay, so log of b base a is equal to x is expressed as b is equal to a to the power x. Then we also talked about the concept where we have the fraction power. So when you have a fraction power, always remember that the denominator to the power gives a root. Then the numerator is the power. So we have x to the power a over b. This is simplified as b root of x to the power a. We also talked about the natural log. So when you have natural log, ln of x, natural log of x, you should know that this is also can also be written as its log of x base e. So there's always the base of exponent there. Okay, thank you so much for your time.